Okay, here we are, lesson 4 on special right triangles. This is the other special right triangle called the 30, 60, 90. I want to introduce you guys to some pretty cool and predictable. You like predictable, don't you? Yeah, Sean's like, yeah, I like my ice cubes and my frosted flakes. Right? Yeah, he loves it. Okay? Don't say ooh.
What did you say?
Did you listen to anything I'm recording right now. This is great. No, you eat it fast so it's colder, right, Sean? Yeah. All right, let's talk about 30, 60, 90s here real quick. And off the bat, this isn't going to make sense. I'm going to be honest with you. You're just going to go, what just happened? Okay. But I'm going to throw a couple things out there. I'm going to throw out an x, I'm going to throw out a 2x, and I'm going to throw out an x times the square root of 3. Those are the ratio of the three sides of a 30, 60, 90. Which one would be the smallest, do you think? X? Oh, dang it. I didn't even look at that part of the slide. I gave it to you, didn't I? Okay. Which one would be smallest? If you looked at these three, let's say x was 1. Which one would be smallest? 1, 2, or square root of 3? Somebody take their calculator, punch in square root of 3 right now. Is it greater than 1? It is not less than 1. Is it? Somebody calculate. Square root of 3 right now. Give me a decimal. 1.73. So if I plugged a 1 in here, I'd get a 1. If I plugged a 1 in here, I'd get a 2. And if I plugged a 1 in here, I'd get 1.73. So you'd agree this would be the longest side, this would be the smallest side, and this would be the one in between, right? Right? Okay, which angle is the smallest, 30, 60, or 90? 30. So the side across from 30, we're going to call x. It's going to be the smallest side. Okay, which is the next largest side? 60. So across from the 60 will be our x root 3. And then the side across from the 90 will be 2x. That means that these two sides right here, their ratio is 1 to 2. Okay? So if I had a 5 here, what would this equal? 10. If I had a 50 here, what would that equal? 100. If I had a 50 here, what would this equal? 50 square root of 3. So let's write down our conjecture here. In a 30, 60, 90, if the shorter leg has a length of m, then the longer legs are the two that form the 90, would be m root 3, and the hypotenuse would be twice whatever m is. Okay, let's look at an example on the next slide. Okay, so here I have long leg, short leg, or hypotenuse. And you're told. Which one are you given? Short leg. I take short leg, and what do I do to get the hypotenuse? Multiply by 2. I double it, right? So that's a 10. And to go short leg to long leg, I multiply by square root of 3, so I get 5 root 3. Okay. What if I have the hypotenuse? What do I do to get the short leg? Divide by 2, and then to get the long leg, multiply by square root of 3. Let's pause for a second. Okay, so let's say that I give you long leg. Okay, so I give you long leg, and it's 10 root, I don't know. Somebody give me an even number. 10 root 4. Well, that'd be 10 times 2. I don't want a perfect square. Okay, we'll go 10 root 6. Somebody threw it out there. Yeah, you're right. Bad teacher. It's a good thing I get paid a lot. So how would I get the short leg if I have the long leg? What do I divide by? Square root of 3. I always multiply and divide by the square root of 3. So this would be 10 square root 6 over square root 3, which would be equivalent to 10 times the square root of what? Square root of 2. How did I get the 2? What? I took the 6 and the 3, and I divided them. Okay. Okay, now how do I go from short leg to hypotenuse? Multiply by 2. Done. 30, 60, 90s. Okay, let's take another look at a problem over here. Actually, you know what I'll have you do? Work with a partner. Take, I don't know, 3 minutes or so, 3 or 4 minutes. Work with them, and we'll come back and look at the answers. Okay, somebody want to volunteer some answers for the first one? Tony, what do you think? This side right here? Yeah, you divide by root 3, you get 9. Good. What's the hypotenuse then? 18. Good. We double that to get the hypotenuse. Here's where many of you got sniped. I reoriented this. Is this side 7 the long leg or the short leg? It's the long leg because it's across from the 60. Therefore, I take that and I divide by the square root of 3 to get the short leg. And I double that to get the hypotenuse. Be careful, right? I did a little Mark Wahlberg from the trees over here. Caught you right in the patella. You went down. You got up with a little bit of a limp, and then you finished it. Okay, let's keep moving. If I want to, guys, this is a classic ACT problem. Classic. Are you ready? I am. This right here is an equilateral triangle. That makes this angle right here, this angle right here, and this angle right here 60 and 60. And I'm not going to write that one up there for the moment for a reason. If I draw a vertical line here, what does that make this angle? 30. Oh, hello, 30, 60, 90, my friend. So to find the area of a triangle, recall the area of a triangle is 1/2 base times height. Oh. So let's talk about that for a moment. 1/2 base times height. If you're talking right now, you need to be quiet because this is very important. So close it for a minute. Okay. Let's recall the base is going to be the full yellow length. The height is going to be the blue length. How in the world am I going to come up with those? Well, I'm going to use what I know about 30, 60, 90s. Okay, so what do we know about this triangle? The sides measure 36 each, right? So that's 36, that's 36, and guess what? What's the yellow length? 36. So I know the base of my triangle is 36. How would I find the height? Well, let's sketch a little 30, 60, 90 here for a moment. I know the hypotenuse is 36. What does that make if this is a 30, what does that make this side right here? Half of that, right? 18, what does that make the long leg? 18 root 3. Oh, that's so cute. That's a nice little height there, right? So now I know that the height is 18 root 3. What happened? Go away. Miss Osby, help. Oh, there you go. Thank you. 18 root 3. Okay, so now comes, how does Mr. Ludd want the answer for this? It depends, okay? Not like the underwear. So, no, yeah, okay. Here's one way I would do it. I would take half of 36 and get 18. And then multiply that again by 18 root 3. And does anybody know what 18 times 18 is? 324, good. So I get 324 root 3. I think it's centimeters. Is it centimeters? That'd be the area of that triangle. Now, if you put it in decimal form and just multiplied it out, I'd be okay with that too on a test, unless you were told to do otherwise. Okay. So you take an equilateral triangle, you split that in half, you've got two 30, 60, 90s. That only works for the equilateral, though. Okay. Is my microphone on? There it is. Let's reconvene. If this length right here, this height is 7 root 3. 7 root 3. What does that make this length right here? 7. And that length and this length are the same. Therefore, what are these two sides? Those are both equal to 14. Some kid is going to do this. It's just how it's going to work. Okay, the answer to this, the perimeter of the triangle is 42. right? 14 times 3 is 42. But some kid is going to do this, and I fool you not. It will happen. I will tell it straight to some kid's face, like, don't assume that this is the length of the entire side. Their answer is going to be 21. They're going to write it. It's just going to happen. I hope it doesn't. If it doesn't, then I'd be pleased. Okay? But don't get fooled. That's just half of the base. That's just half of the base. So we got to add it, get 14, and then multiply it by 3 to get all 3 sides, aka the perimeter. Okay, that's it. Like, subscribe, comment below. 100th subscriber to my channel gets a $5 gift card to GNC or the general store, whichever they want. I know some of you, you want to get a trinket for your reindeer, pet reindeer at home or whatever. Maybe I'll go general store. Whatever. Sean, you haven't made up any fake emails to sub to my...
Not yet. I'm waiting for you to get to 98.
Okay, that's a good plan. Unless you went home tonight and just made 47 emails and subscribed that many times. No? Okay. All right, fair enough. Get to it. 30, 60, 90s. We're